Hey, Algebra 1, we're going to talk about trigonometric ratios. Remember, a ratio is a comparison of two things by division. Fraction, kind of looks like a fraction. So we're going to compare the lengths of sides of right triangles. Now, the most common trigonometric ratios are sine, cosine, and tangent, and those are just ratios. So I'm looking at a triangle and I'm going to compare sides. So what do you need to know? Now, hopefully you remember that when you have a right triangle, and this only works for right triangles, that your right angle is always across from your hypotenuse. Okay, I'm just going to abbreviate hypotenuse. Okay, so if I'm talking about this angle, and I'm going to call it x, okay, and I might know some degrees, I might not, but I need to know that this is the hypotenuse. This side is called adjacent. It's kind of next to, it's a part of that angle with the hypotenuse. This side is my opposite, okay? Those are the things I need to remember, because when I'm talking about an angle, I need to know, is it opposite, adjacent, or hypotenuse? Those are the numbers I'm going to compare. Okay? Now, mnemonics. Those are things that help you remember stuff. So, Katoa. SOHCAHTOA. Okay? And what that means is that my sine is equal to the opposite over the hypotenuse. It's just a comparison. Okay, it's just a comparison. My cosine, and on your calculator, I probably should leave this E off because on your calculator, it doesn't put it there, but it's there. Okay? It's a sin, cos, and tangent. Okay. Cosine, adjacent over hypotenuse. Adjacent over hypotenuse. And then the tangent, opposite over adjacent. So SOHCAHTOA helps me know how to set it up. Okay? If I had my basic, now I'm not measuring, so I'm just kind of guesstimating. If I had my basic 5, 4, 3 right triangle, and I'm talking about angle A, okay? This is my adjacent, this is my hypotenuse, this is my opposite. So the sine of A, okay, opposite over hypotenuse, sine, opposite over hypotenuse, is 3 over 5. My cosine of A, adjacent over hypotenuse, is 4/5. My tangent of A is opposite over adjacent, so that's 3/4. Okay? And if we were in class, we would have done that one on the board. Now, just in case you didn't pay attention to the example in the book, this 3, 4, 5 right triangle is similar to the one in the book that was 9, 12, and 15. 9, 12, 15. They're similar triangles. Okay, the ratios of corresponding sides would be congruent. It's the same triangle. The sides are just 3 times as big. Notice, sine, cosine, and tangent are the same thing. Just like angle A in both triangles would have to be the same thing. Okay. I don't want to talk about example 2 because that's just too easy. All right, that's just using your calculator. Do remember that your calculator should be in degrees. Now, when I'm solving a triangle, Let's say my triangle looks like guided practice 3A. So it looks kind of like this, and they call this A, B, C. This is my right angle, and they tell me that this is 7. Oh, and they tell me that this is 35 degrees. Whenever I'm solving a triangle, I need to find 3 measures. Okay, I've got to find these sides. I'm going to call this X and this Y, and I've got to find this angle. Now, the angle is the easiest part because these two acute angles have to add up to 90 degrees. 90 plus 90 is 180. So these two have to add up to 90 degrees. So the measure of angle B equals 90 minus 35, which is 55 degrees. Okay, now I'm looking at this angle A because it's 35 degrees. What is this? That's my hypotenuse. So I go back to my SOHCAHTOA and I say, oh, which ones have hypotenuse? Sine and cosine. So to find my 2 missing sides, I'm going to use sine and cosine. The sine of 35 equals opposite over hypotenuse. Opposite is y over the hypotenuse, which is 7. Now, I like to turn this into a proportion and use the rule of 3. Okay? The rule of 3 says you cross multiply the 2 that you can and divide by the third one. Well, dividing by 1 isn't going to change anything. So to find y, I'm really going to do 7 times the sine of 35. Okay? 7 times the sine of 35. So on my handy dandy graphing calculator, ooh, what have I been doing? Okay. 7 times sine 35 equals, that equals about 4.01. Since we're rounding to the nearest tenth, that's about 4.0. I leave the 0 because that just says, hey, you know, there was more after it. Okay, to find x, that's my adjacent, so that's my cosine. Cosine of 35 equals x over 7. And again, if I turn it into a proportion, then I can use my rule of 3. Cross multiply the 2 you can, divide by the third one. So I'm really doing 7 times cosine 35. All right. 7 times cosine 35, and that gives me about 5.7. So I've got my 3 measures. Can I check? Well, I've got 3 sides of a triangle, okay? So 4 squared plus 5.7 squared should be close to 7 squared or 49. 4 squared is 16 plus 5.7 squared, 48.49. That's pretty close. Okay? Now, it's not going to be exact because I rounded things off. Okay? So hopefully that makes sense. Other ways to check? Well, let's see. If I look at this sine of 35, well, that's 4/7. So if I take 4 divided by 7, I get 0.57142857. Okay, so that should be the same as sine of 35. Cool, man, those are really close. It's off by like 200s. Okay? And all I did was hit sine of 35, and that has to equal 4/7. So a lot of ways to check. That's why I like these so much. Okay? 3B, guided practice. So they drew it kind of like this. And my picture is not perfect. Okay? Because I'm drawing it freehand. I'm going to call this X. This is 11. This is C. This is A. This is B. I've got to find this. I've got to find this. We'll call this Y. Okay, so, oh, I had some degrees. 51 degrees. Okay, so the first thing I look at is angle B is easy. The measure of angle B is 90 minus 51. Oops, 90 minus 51, which is 39. So this is 39 degrees. Got that part? That's the easy part. Okay, now to find x, that's my adjacent. And what do I know? This is my opposite. Well, opposite over adjacent. Well, what am I using? So if I look at SOHCAHTOA, opposite. I'm going to use sine to find the hypotenuse, tangent to find the adjacent. So to find x, I'm going to use the tangent of 51, opposite over adjacent, 11 over x. Now see, if I write it as a proportion and I use my rule of 3, cross multiply the two I can, divide by the third one, I'm really doing 11 divided by tangent of 51. Okay, so I get out my handy dandy calculator. 11 divided by tangent 51, and that gives me about 8.9. So x is about 8.9. To find the hypotenuse, I've got to use sine, opposite over hypotenuse. So the sine of 51 equals 11 over y. And again, see, this way I know whether I'm multiplying or dividing. 11 times 1 divided by sine of 51. Okay? So I've got 11 divided by sine 51. And I type it into my calculator. And that's about 14.2. Okay, so a lot of ways I could check. I could use the Pythagorean theorem. I could say 11 divided by 14.2 would equal the same or very close to the sine of 51. But I've got my 3 measures. I could use the Pythagorean theorem and the 3 sides to check. A lot of things I could do. Okay? They give you a word problem, draw a picture. In example 5, we're trying to find the measure of an angle. Okay? So in the one they give you, it looks kind of like this. They call this x, this 14, this y, and this 5. Okay, x, y, z. Okay? And I want to find the measure of angle y. Okay? I actually want to find the measure of angle x. But we'll find y too. Okay? Measure of angle x. So I think about what I know. Well, what is 5? 5 is the opposite. 14 is across from that right angle, so it's the hypotenuse. Well, opposite over hypotenuse is the sine. So whenever I'm trying to find an angle measure, I want to do sine -1. That's an inverse. Okay? Of 5/14. And I can put that in as a fraction or as a division problem. Either way, it will work. Okay, so second, sine. I usually do a division problem. 5 divided by 14 equals about 20.9, but we round to the nearest whole number, so that's about 21 degrees. Okay? Now, if I wanted to find y, what is 5? So this is angle x. If I wanted to find the measure of angle y, well, this is the adjacent and the hypotenuse. So that's cosine. So if I do second cosine 5 divided by 14, I get about 69.1, which is really about 69 degrees. Now notice, 69 plus 21 adds up to 90 degrees. So see, it works on so many levels. Hope that helps. Just text me or send me an email if you have questions. Talk to you later. Bye.